Hey there, making a video on showing you how to make high precision and most importantly scrap metal cheap CNC parts for your plasma cutters, lathes, mills, pretty much anything you want. So the typical problems that traditionally they make CNC machines out of is sheet metal or cold rolled or hot rolled sheets, steel, beams, etc. The issue with these materials is that they're strong, but they're very flexible, right? They're ductile. They're ductile. Sorry, but pretty much they're not stiff, right? You want a CNC machine to be very, very stiff. So a cast part is less strong than a rolled part or an extruded, for example, extruded aluminum, but it's a lot more stiff, right? So it bends way less, which is exactly what you want with CNC milling. The second thing about metal is vibrations. So the highest accuracy or precision CNC machines use what's called granite epoxy bases. So they'll use granite rocks mixed in epoxy, and they'll cast entire epoxy resin, gantries, frames, etc. And the issue with that is that it's super expensive. Although yes, the granite is for stiffening. One of the major reasons why they add a lot of granite is just to reduce the epoxy amount. It is very expensive. A gallon, especially with the current prices, easily goes for like over $200 depending on the type. So super expensive. There's a guy on, I forgot his name, I'll post a link about it. Great guy, and he's the one that inspired me to do this. And what there's a research about this in which what you do is you cast the metal part that you need, and then you use a thin layer of epoxy as a dampening material between your linear rail and your frame. So you're able to buy these linear rails off Amazon, eBay for like $50, $100 each, right? Like 2 meters long, super dirt cheap. Ball screws, very cheap to buy linear control systems. The issue is the frame, right? With this, as anyone who works with cast materials knows that there's a bit of a ringing to it. So by adding that epoxy layer between the rails and this, you're adding a dampening effect. And then second benefit about that, and which I'm using for my CNC plasma cutter, is the issue with especially sand cast aluminum parts or sand cast metal parts is the surface is very rough. I don't know if you're able to see here, but there's very rough aspects. Like you see this little bump here, there's a bunch of holes, pits, etc. And the first one that I did, I put 2 linear rail mounts, whatever, brackets, and they were, I guess, the surface place was slightly misaligned, so when I tightened it, it was slightly hard to roll this piece. So by adding a little piece of epoxy, I was able to smooth it out. I used another secondary flat surface, which I knew as a reference, I put it on top, allowed it to cure, removed the top layer, got myself a perfectly flat layer that I could mount the brackets to, bolt it from the back, and perfectly aligned, perfectly smooth, no issues. So this has already been cast. I'll make another video about casting. There's a million videos about casting online. This was done via lost foam method. I've done many experiments with casting, and I'm still learning. It is a very difficult part. The hardest thing about casting is the mold. You'll spend way more money on the mold than the material, primarily in time. And sometimes materials. There's these things. There's this certain. It's multiple different castings. I'll make another video about it. But the cheapest way I've found to make CNC parts is lost foam. So you just cut the foam parts. I use duct tape, and actually you can see a little bit of the duct tape that was, because this pour was pretty cold. So you can see a bit of the duct tape that wasn't burnt out completely. And made my, whatever shape I needed. And then to remove this top layer, on the first casting I did, I used a Sawzall. It was very slow, very pain in the ass. Quickly wore out my blades. But for this one, I'm gonna make relief cuts with a skill saw, with a metal cutting blade, and then just whack it with a hammer. And that's what I did, well, kind of with the first one. I used a Sawzall, got tired of that, used the hammer, and perfect cuts. So I'm gonna show you that process. Alrighty, so that's the relief cuts. Next is the hammer part. Alrighty, so once you got the relief cuts cut in, all you gotta do is whack it with a hammer. That easy. Keep in mind the relief cuts isn't exactly to, if you need, to remove material where you need to remove material. Technically speaking, I could leave these, this excess material. It doesn't, I'm just gonna have a beam here, dismounted to the angle iron, so it's just so I could remelt it down, so I'm not wasting a little more. Very easy. This one I'm gonna try hard and wet. Didn't even make a relief cut on that one. As you see, clean cut. See where the aluminum or where the foam lead, and again I'll cut this off, or I can, let me try whacking some more. That should be good. The rest I'll just grind this piece off, flatten it off, so I can have the gantry on top. Easy, super simple, way easier than Sawzall. And while I'm grounding, I'm gonna brush off all the little, spiky points so that the second layer will, or the gantry beam will set on top pretty well without the spiky bumps. There we go, pretty good. Last one is this surface right here, and next step is epoxy. Good. Alrighty. Alright, now that once I got the surface that I want to mount my flat part on, all clean and shiny. Next part is the angle, or just a wire brush it. That'll clean off all the grime, whatever. It takes 5 seconds to do, and make sure that the epoxy has a very good surface to bind to. There we go. I don't know if you're able to see, but very shiny and pretty. Love it. Beautiful. Alrighty, so once I got the surface all clean, shiny, no high spots, next thing we're going to level it. Very simple. I had to get some washers, get a level. Seems pretty good on this aspect, or better to measure this way. Yeah, a little high on here. Just going to add 2 washers. There you go. 1 more washer. Another washer. Want to get it as flat as possible so that you have the least, you have to use the least amount of epoxy. Otherwise you're going to have to, raise it up a lot. It's pretty much flat, but let's give it another one. Perfect. Okay, next one is this way. And it seems like we got a lot of washers. Not sure how many. Let's put in 6. Okay. That was a little too much. Remove 2. Perfect. This one. Put another one here. Perfect. Alrighty, we got it flat. Next step is to mix up the epoxy. Alrighty, so here's me mixing the epoxy resin. So 3 things you're gonna need. Obviously the material, clean. Secondly, you're gonna need the actual epoxy and sand. And thirdly, you're gonna need a surface material to flatten it all out with, and a separator. I've tried mineral oil on my first attempt. This is on the other side. I'll show you about it. But you can see that there was some epoxy resin that hardened and was attached to this plate. So I'm gonna try this time with a wax paper. You can also probably plastic, any sort of separator really, just so so your surface material isn't permanently attached to this, and so it doesn't damage any resin if it does attach. Alrighty. In my case, I'm using polyester resin. This is used in fiberglass. I would highly suggest use epoxy. In my case, since I'm just using this for plasma cutting, I don't need high precision. I mean, so far it seems to do the job. It does a pretty great. So here's the sand and the polyester resin. Again, using fiberglass resin. I highly suggest epoxy resin, but in my case this will be fine. Just pour it in. I'm suggesting a lot less than that, just to start it out, see what that, see how much more you need, right? And this seems just the right amount. Oh, that's perfect. I was lucky in that case. But add a little bit at a time. Mix it up, add a little bit more, mix it up, add a little bit more. Kind of want it like this, where it's not forming a liquid on the top, right? So it's kind of like all colloidal, I guess you could say. If you add too much, pretty much you'll notice that the sand settles on the bottom, and there'll be a thin layer of the resin on top. This is just right. I'm very lucky with how much I put in. Next, since I'm using the resin, I need a catalyst. Again, just add a generous amount. Mix it up. There's just a stick I found on the ground. Should also put a piece of paper on the bottom so it doesn't muck up my table. There's a high precision table. Got it at an auction for like 150 bucks. It's like 1-inch solid, a little steel. It has webbing in it. It's absolutely fantastic. I'm an idiot. Forgot about these. Sorry, we can put this on top. Put this on top of this. There we go. Should have done this all before I mixed this up, but we're fine. Okay, level's perfect. Next, we add the mixture. Make sure to rub it into the metal so it's nice and sticky on the surface material. Spread it out evenly. Now we get the surface material that we want to reference off, and just put it on top. Make sure that all the epoxy is enough, and that seems right. It's oozing from the side, so perfect. I'll wait till this finishes. Got a lot of extra epoxy left. So yeah, as you see, you just need a tiny amount, of the resin, and it's more than enough. I mean, if you'd like to build it up, you could probably use like Play-Doh or some rubber material, and align it. I was also thinking of a heat treat, so like heat it down so it's pretty much water leveling itself. There's a lot of methods you can try with, but so far I'm very happy with this. Good. Alrighty, so here's the resin a day later. Hopefully we can just peel it right off, and yes we can. Easy. Look at that. You got ourselves a flat surface. Over here towards the edge it started dipping off, but that's not where I wanted the what's it called, the mounts, because they only need this area right here. But yeah, I mean it's flat. You can check for the level. And perfect. Easy, clean, precise. And with this epoxy, we can see that it's pretty hard. Sorry, with the fiberglass resin, we can see that it's very rigid, because that sand just acts as the yeah, it's hard. I mean, it's definitely good. I'm happy with this. I'm happy. Alrighty, next steps is simple layouts, drilling the holes, you know, basic stuff. Nothing complicated. Drawn up on AutoCAD. You use really any CAD modeling software. Once you do have it printed, make sure you measure it with a caliper or, you know, ruler or whatever. Make sure that you got the scale and everything right. Yeah, a lot of people like to just glue this down. I'll just be using clamps and measure this approximately. Again, it doesn't need to be accurate, just, you know, so it's not completely way off. Good enough. Just clamp it down. You know, much more suggests that you actually take the patience to glue it down, but I don't have that. Okay, once you got that, you just get your, put it right on the mark and hammer it. 1, 2, 3. See, it's jumping out, and that's why it's a good idea to glue it down instead. There we go. And then I'm gonna double check that the all right this way. Alrighty, so here's the castings. The first one. Here's the second one. Just to represent or show what exactly I'm doing here. So this whole gantry, eventually I do want to cast this whole beam. Obviously, I'm working on creating an area where I'll be able to cast large pieces like these. But for now, I'm just, you know, doing this for starters. I'm going to switch it out with the roller chain because this one was stretching way too much. It was a nice experiment, learning lessons. But yeah, this is pretty much what I'm doing these castings for, and they are solid. I mean, I can feel that they are. I mean, I'm very happy with these. Very happy.